Hey there. What if I told you there's a formula that connects the virtual exponential directly to the gamma function, one of the most profound mathematical objects out there? Today, we're going to unveil what I call the virtual reflection formula. This result bridges the virtual Euler formula with the fundamental properties of special functions. And don't worry, we'll derive it, verify it, and explore its deeper meaning step by step. Let's dive in. At the heart of this derivation is the virtual Euler formula, which extends Euler's classic result into the virtual number system. Here's how it looks. E raised to the power of j times x equals cosine of pi times x plus j times sine of pi times x divided by pi. Now let me break this down for you. In this formula, j is the virtual unit defined as the natural logarithm of -1. That's different from the imaginary unit I you might be familiar with. This equation describes how exponentiation with j relates to trigonometric functions in a completely new way. This formula will serve as our foundation, linking exponential functions to trigonometric ones. But our goal is to express it in terms of the gamma function, revealing a hidden reflection symmetry. Now let's talk about the gamma function. The gamma function generalizes the factorial to non-integer values. It satisfies a remarkable identity known as the reflection formula, which says gamma of x times gamma of 1 minus x equals pi divided by sine of pi times x. This equation hints at a deeper relationship between trigonometric functions and factorial-like structures. From this, we can rewrite sine of pi times x as pi divided by gamma of x times gamma of 1 minus x. Similarly, there's an analogous identity for cosine. Cosine of pi times x equals pi divided by gamma of 1/2 plus x times gamma of 1/2 minus x. These expressions are going to help us transform the virtual Euler formula into something even more powerful. Starting with the virtual Euler formula, e raised to the power of j times x equals cosine of pi times x plus j times sine of pi times x divided by pi. We replace cosine of pi times x and sine of pi times x using their gamma function representations. After substitution, the formula becomes e raised to the power of j times x equals pi divided by gamma of 1/2 plus x times gamma of 1/2 minus x plus j times 1 divided by gamma of x times gamma of 1 minus x. And there it is. This is the virtual reflection formula, a bridge between the virtual Euler formula and the properties of the gamma function. But how do we know this formula actually works? Let's verify it for specific values of x. Case 1, when x equals 1 left side. From the virtual Euler formula, we know that e raised to the power of j times 1 equals e raised to the power of j, which equals -1. Right side, first, we compute the required gamma values. For gamma of 3/2, we get 1/2 times the square root of pi. For gamma of -1/2, we get -2 times the square root of pi. For gamma of 1, we know it's just 1. And for gamma of 0, it's undefined, so we treat it as infinity. Substituting these into the virtual reflection formula, e raised to the power of j times 1 equals pi divided by 1/2 times the square root of pi times -2 times the square root of pi plus j times 1 divided by 1 times infinity. Simplifying this, pi divided by negative pi plus j times 0 equals -1. Since both sides match, the formula holds for x equals 1. Case 2, when x equals 1/2 left side, we know that e raised to the power of j times 1/2 equals cosine of pi over 2 plus j times sine of pi over 2 divided by pi. Cosine of pi over 2 is 0 and sine of pi over 2 is 1, so this simplifies to j divided by pi. Right side, computing the gamma values. Gamma of 1 equals 1, gamma of 0 is treated as infinity, and gamma of 1/2 equals the square root of pi. Substituting these into the virtual reflection formula, e raised to the power of j times 1/2 equals pi divided by 1 times infinity plus j times 1 divided by the square root of pi times the square root of pi. Simplifying this, 0 plus j times 1 over pi equals j divided by pi. Since both sides match, the formula holds for x equals 1/2. The gamma function has singularities at non-positive integers, which means it's undefined at those points. To handle this, if gamma of x is undefined, we treat it as infinity. This ensures that terms like 1 divided by gamma of 0 evaluate to 0, maintaining consistency. For example, in our verification, treating gamma of 0 as infinity allowed the formula to hold at x equals 1/2 and x equals 1. If you're as excited about this as I am, hit that like button, share this video, and let's spread the word about the virtual number system. And if you have questions or ideas, drop them in the comments below. Let's explore this new frontier together.